Okay, example 1. We have 2 goals for each of these problems. We are going to first determine the end behavior just like we did, and then we're going to figure out its domain and range, which are the intervals we did yesterday with the brackets and parentheses. So, look at example 1. Easy peasy. On the left, what does it do? Positive infinity. On the right, what does it do? Negative infinity. So let's write it the official way. As x approaches, do you want to do the positive first? Okay, so this is talking about which side? X approaches positive infinity. Where's positive infinity on that? That's this side, right? This is...
Yeah.
So this is describing the right side. So what's it doing on the right side? On the right side, what's it doing? Going towards negative infinity. It doesn't matter if you describe the right side or the left side first. Just make sure you know which is which. X approaching positive infinity means the right side. X approaching negative infinity means the left side. If it's going to help you, you can write that down. You can say, hey, just a note to self. Wow, I just messed it up. This means right side. This means left side. If you want a note to self, give yourself a note. Hey, x going towards positive infinity, that's the right. X going towards negative infinity, that's the left. Give yourself a note. So on the left, f of x is going towards positive infinity. It's going up forever and ever and ever. That's it. There's your end behaviors. Now the fun part. This is like what we did yesterday. The domain and the range. So we need to create 2 intervals. I'm lazy. I don't like to write the word domain, so I just do a bolded D. That means domain. If you remember from our thinking task, the domain is what values? The x or the y? The domain is the x. So let's think about the store. Remember for that store problem, or the restaurant? The domain was the hours it was open, because that was the x-axis. So if we look at this graph, how far to the left will this line go? It will go to the left forever, won't it? If you extend it off the wall, through the roof of the ceiling, it'll keep going left a little bit forever. Same with on the right. This line will continue going to the right forever. So you can kind of think about, when is this function open for business? How far to the left will it go? Forever. Negative infinity, right? How far to the right will it go? For infinity. So this graph starts at negative infinity, and it goes towards positive infinity. To the left forever, to the right forever, and everywhere in between. Isn't this x, or this function, going to be at every x value? No matter what number you pick, it'll eventually get there. Do infinities get parentheses or brackets? Do you remember from yesterday? Parentheses always. So parentheses both sides. That's the domain. And this just looks like nothing to someone who doesn't know math. But to us, this means our function goes to the left forever, and it goes to the right forever. Everywhere in between, from all the way to negative infinity, all the way to positive infinity, every number. The range talks about the y values. So now, instead of talking about left to right, we're going to talk about up and down. How low does this bad boy go? Forever low. But in math, I'm not going to write forever low and turn it into my professor. I'm going to write negative infinity. And how high will this function go? Positive infinity. And just like we said before, infinities get parentheses. That's the domain and range. when we were talking about our restaurant, the domain was when the store hours it was open. That was the left to right on our graph. The range was that 0 to 200 people because that's the lowest amount of people and the highest amount of people that it could have. This graph just happens to go left and right forever, and it could go down and up forever. So it can be everywhere. Example 1 in the books, 3 to go. We step it up a little bit each time. Am I good to go next? Got it? Copying still? Example 2. Now I try to be sneaky and tricky here. Okay, I'm going to put a little point here. What point is this? The point over 4, and then I don't go up or down, so 0. 4, 0. Okay, that's important because we're about to talk about the end behavior. Now, this is different because we never described an end behavior that's a point. We've always done it where it's going somewhere forever. Okay, so this graph isn't actually approaching anything, is it? Where is it at the start? X equals 4, and what's the function equal? X equals 4, and the function equals 0. Remember, the first number is your x value. The second number is your function value, f of x or y. That's actually the same thing. If you ever hear me say f of x, it's the same thing as me saying y. Okay? Just like the words small and little are the same, f of x and y to you in the next couple days should start being the same word. F of x, y, same thing. Yeah. Huh? How come you don't just say y? Would you rather me say y? I just interchanged. You're right. It is strange. It's because y is for like a point notation when you're talking about a point. But when we're specifically talking about a function, mathematicians just have decided that instead of using the term y, we're going to use the term f of x. Because f of x means if you put the x value inside of a function, this is what you get. But we just grow up always calling it y until we get to algebra 2. But just know when I say f of x or y, it's the same thing. But you're right. It's just like in English. Why do we have the word little when there's the word small? You know? Math wanted to be special too. They're like, why? We're also going to call it f of x, you know? Just like plus and adding mean the same thing. Multiplying and the product mean the same thing. There's lots of words that mean each other. Okay, so let's determine the end behaviors. X isn't approaching 4, x equals 4. When x equals 4, that's the left side. On the left side, x equals 4, and f of x, or y, equals 0. It's not approaching anything. We're not going towards infinity or negative infinity. It's a point. X is 4 when the function is 0. It's just a point. So if it's at a point, you just say, hey, the end behavior on the left is just a point 4, 0. Now on the right side, do we have a point? No, we're approaching. So we have to go back to saying the word as. As the right side is infinity or negative infinity? Positive infinity. Where's the function going to go? Up forever, positive infinity. Yep, that's our right side. Plus infinity is perfectly fine. Actually, lots of people do that. Even professors and doctorates of math, yeah. If you write positive, like literally plus infinity, yep. That is okay. Again, I'm lazy. I like to minimal writing. But I think it looks fancy when you put plus infinity, so that's good. Okay, domain and range. Now, we haven't necessarily done domain and range yet, but we did do intervals, and intervals are the same thing as domain and range. So, remember domain is our x, So let's look at the x-axis. When you look at domain, you should never ever look at this y-axis. We don't care about any of these numbers going up and down. We only care about the numbers on the x-axis. So looking at the numbers on the x-axis, I'm going to ask you a question. Is this function open for business when x is 0? Where is x equals 0? Right? Is there a function here? Is there a function at 2? Not yet. When is the first time our function is open for business?
4.
At 4. That is the beginning of the function. It starts at 4. When does it end? It doesn't end, so we write infinity. This function starts at 4 and goes towards infinity. Can't ever be at 0. It will never be at -1 or anything over there towards Kravitz. 4 is where it starts. But we have to be careful. Am I going to put parentheses or brackets? And why a bracket? It's a closed circle at 4. It is at 4, so it's a bracket. And infinities always get parentheses. That's the domain. Again, this just looks like nonsense. It looks like shapes and numbers and a sideways 8, but this means our function exists from 4 to infinity. How do I know it was a closed circle? Yes, you would have a point. It's a bad image. It would have a clear point when I give you a problem. I just was lazy making it. But yes, you would be given a closed circle or an open circle. You would know. You wouldn't have to guess. Range. Bolded R. Aren't bolded R's fun to draw? Our range, now we're talking about the, not x, y, or f of x, whichever one you want to use. So you just ignore all the numbers on the x-axis. You're only looking at the up and down. What is the lowest it goes? What is the y value, the f of x value? Oh,
0.
yeah. See it right here? What's the lowest it goes? 0. Stop. 0 is the lowest it goes. It never goes below 0, does it? So our range starts at 0, and how high up is it going to go? To infinity. Okay, now let's figure out the bracket game. What does 0 count as being a point? It counts. And infinity gets a shaboom, done. Am I going too slow? Can we go faster? Or is this good speed?
Good speed.
Good speed?
Not like a secret
Alright, sometimes I like to talk my mouth out, and you just tell me, Tokar, come on, let's get it. We'll go faster. This is where the real tricks begins. And again, I was lazy. What should be right here? There should be a point. I made these graphs in Desmos, and it's annoying to add points, so. Okay, so let's determine our end behavior. What is the end behavior on the left? Is it approaching something, or does it equal something? Is there an arrow or a point on the left?
Oh, it's right here.
If there's a point, where are we on the left side of the function? At the point 0, 2. So, when x equals 0, remember first number is x, second number is f of x. When x equals 0, what does f of x equal? 2. That's it. This is just a fancy way of saying it's the point 0, 2. That's what that means. Look. X 0, 2. This is math language for, hey, where do we start? We start at the point 0, 2. That's where we start. 0, 2, that's where it starts. When x is 0, f of x is 2. Right side, we are not at a point, so let's do the right side. Give it to me as x approaches positive infinity, because this way is positive infinity. As x approaches infinity, where does our function go? Approaches positive infinity. Yep, perfect. Nice job. Does everyone feel smart? Fancy? Domain. When I'm talking about domain, I'm only looking at which axis? X. We do not care about any of the y values, only the x values. How far left does this graph go? I heard it. 0. Does this graph ever go to the left of 0? Never. It starts at 0. And when does it end? How far to the right will it go? Forever. Now let's figure out the bracket parenthesis game. What does 0 get? It's closed, so we get a. Infinity always gets parentheses. Alright, are you ready? Think very hard before you say anything. I'm going to ask you what the lowest value in the range is. Think. Range, we're talking about our y-axis. So we're only looking at our y's. We do not care about the x-axis. What is the lowest number in our range? I know why you want to say 2. Why is it 1? It curves down to 1. Isn't this the lowest part of the graph right here? Right there. That's the lowest point. So does the first point always count as the lowest point? No. You have to look on your graph and find the lowest point. I get why you want to say 2, because in all the other examples we did, it was always the first point. But because this graph dips down before it goes back up, the actual lowest point, the lowest y value is 1. That's the lowest. How high will this graph go? Infinity. Now the graph hits this point, so it's a bracket, and infinity is a parenthesis. Uno más. 1 to go. I think we're done at 40. Are we done at 46? 56? 56? Okay, good. Ooh. Tell me when I can go next. Tell me if that made sense. Domain and range. Range was tricky on this problem. Range was tricky. We're good? What would my Yelp review be right now? 5 out of 5? 4.5 out of 5? 5 out of 5? And I'd get a comment? No comment? Okay. I'd leave you guys all good, student Yelp. And I'd leave a comment. Excellent. ... More to come. Thumbs up emoji. Let's start it. There were some people still writing, so I was just trying to buy myself some time. Okay. Ooh, what does this one have? An open circle. And we can start calling them holes as well. That is technically what they're called. I just was calling them open circles yesterday, but they're called holes. Okay. This is very tricky, because on the left, are we approaching something or are we equal to something? Does the function equal the point 1, 2? Does the function get to the point 1, 2? It does. If you're walking on that line and you're standing at the point 1, 2, what are you doing? You're dying because you just fell into the great grid abyss. Can you stand on this point? No, because it's a hole. I know, this is a trick question. I set you all up. So x never actually equals 1. It's going to approach 1. Does that make sense? Our graph gets really, 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 really close to that point, but it never actually gets there. It's like an endless Tom and Jerry chase. So x is approaching, and I should have wrote the word as x approaches 1, because this is our x value. It's getting really, really, really close to it. It's never going to get there. If it was a closed circle, it would equal 1, but it's open, it's a hole. As x approaches 1, f of x approaches positive 2. Yep. We're approaching the point. We're getting close to the point 1, 2. We're never getting there. That's what that means. Right side, easy peasy. As x approaches positive infinity, that's to the right. Where's f of x going? Positive infinity. Nice job. That one's a tricky one. That's the hardest we'd ever. I think that's the hardest one you'd get. A couple tricks in there. Okay, domain and range. Capital D for domain. Or if you tilt your head sideways, a very sad emoji. If we're looking at the x-axis, how far? What's the farthest left this function gets? I heard it. 1. Do we ever get farther to the left than 1? Nope. The farthest this graph goes is left. And again, if you think about that restaurant problem, if you can kind of think of it like, oh, this function restaurant opens up at 1. Anything before 1, it's closed. There's no function happening there. So from 1 to, how far to the right will this graph go? Positive infinity. Now we got to be careful, because now it's time to pick between brackets and parentheses. Infinity, we know, gets a parentheses. Does our graph get to the number 1? So it doesn't deserve brackets. It's a lowly parenthesis. Last thing, range. And we're done. What's the lowest this graph goes? 2. This doesn't have a trick like example 3. 2, the starting point was the lowest point. How high up will it go? What goes on both sides? Parentheses, parentheses. That's a wrap. End behavior, domain, and range.